Welcome to This Explainer. I'm absolutely thrilled you're tuning in today because we're tackling a challenge that is literally redefining how we live and work on the road. We're going to break down the absolute latest, most advanced off-grid connectivity solutions out there right now. I mean, if you've ever tried to maintain a stable internet connection while traveling off the beaten path, you know it can be incredibly frustrating. But today, we're diving into Generation 5 systems architecture, a technology that's fundamentally solving this whole problem. So let's jump right in. All right, picture this for a second. You've driven your premium motorhome out to this stunning, totally remote national park. You've got a breathtaking view right out the window, fresh cup of coffee in hand, and a critical corporate video call starting in exactly 2 minutes. So the real question is, can you actually run a boardroom from the backwoods without your connection completely dropping right as you make your most important point? For a really long time, the answer was honestly just no. You are entirely at the mercy of spotty cellular coverage or satellite signals that get blocked if you just look at them wrong. To understand how we finally fix this, here's our quick roadmap for today's explainer. Number 1, the modern nomad problem. Number 2, Gen 5 connectivity explained. Number 3, empowering the remote executive. And finally, number 4, WISP base versus LTE. Kicking things off with Section 1, the modern nomad problem, or as it's often called, $140 billion in connectivity chaos. Okay, this number is just staggering. $140 billion. That is the economic impact of the U.S. recreational vehicle industry right now, covering something like 11 million RV-owning households. This isn't just some niche weekend hobby anymore, you know? It is a massive, thriving sector. But zooming in, a very specific, high-value, totally tech-dependent demographic has emerged here, and they are the ones driving the need for completely new solutions. The industry actually calls this group the modern nomad. We're talking about a fairly affluent demographic, usually between 35 and 65 years old. These are remote executives, entrepreneurs, families who are out there road schooling their kids. And they're driving these premium motorhomes, you know, the high-end Class A, Super C rigs, often valued well over $150,000. For these folks, stable internet is definitely not a luxury. It's an absolute necessity. They need it for high-def streaming, running businesses, managing investments, the whole shebang. They operate on this buy once, cry once philosophy. They want convenience, they want simplicity, and they'll happily pay for an enterprise-grade solution. Because the irony is, spending $150,000 on a luxury rig doesn't somehow buy you a magic internet button. Despite having these incredible setups, what they're actually dealing with is severe connectivity chaos. Let's be real, the traditional consumer DIY patchwork is a nightmare. People end up relying on completely unusable campground Wi-Fi, dealing with dropped video calls the second they hit a remote area, and trying to manage these incredibly fragile installations. Plus, one of the biggest headaches is the power drain. Nomads are constantly draining their battery banks using power-hungry AC inverters just to keep a standard internet router alive. And good luck getting unified tech support for that mess. But enter the dereticular RIOS Sovereign Mobile node. It replaces that exact chaos with unbreakable multi-carrier bonding and automatic satellite failover. And instead of draining your battery through an AC inverter, it runs on a super efficient direct-to-12V power framework. It basically takes enterprise-grade network performance and hides it behind a really clean, intuitive system that actually comes with support. Moving right along to Section 2, Gen 5 Connectivity Explained, the absolute end of battery drain and dropped calls. This is where we get into the core of the Gen 5 systems architecture, created by the Sovereign Stack Consortium, and it starts with the WISP in a Box series. By the way, WISP stands for Wireless Internet Service Provider. So instead of having this fragile, tangled mess of separate modems and routers and software, this tech consolidates your cellular and satellite bonding into one ultra-durable, modular communications engine. It's just one cohesive, solid-state unit that's actually built to handle the rigors of being on the road. Now, this is where the engineering gets super cool. It is 100% solid-state. Actually, it's not just cool, it's a massive safety feature. Directical has completely ripped out the internal chemical batteries that you'd normally find in a standard mobile hotspot. Think about it. In extreme heat, like trapped inside an RV dashboard or an engine compartment, standard batteries can swell up, melt, or literally catch fire. So by ditching the battery altogether, the system runs safely directly off the vehicle's 12V to 48V DC power bus. They pulled us off using a proprietary 10K ohm BSI spoofing resistor circuit. I know that sounds super technical, but the bottom line? It completely neutralizes the fire hazard and lets the unit run perfectly fine in scorching temperatures up to 60 degrees Celsius. So what happens out in the real world when things go sideways? Let's say you're connected via a low Earth orbit satellite like Starlink, and out of nowhere, your line of sight gets blocked by a huge tree canopy. With most commercial dual WAN routers, you're waiting 10 to 30 agonizing seconds for it to realize it dropped and switch over. If you're on a video call, you're frozen. You've already lost your audience. But with Gen 5, there's an embedded pfSense routing layer that is constantly evaluating your connection health in real time. The exact millisecond that satellite gets obstructed, the system executes an automated packet-level failover straight to your bonded cellular line. It's totally seamless. We are talking zero latency, zero stream disruption. Which perfectly cues up Section 3, empowering the remote executive. We're talking unbroken streams and air-gapped security. If you're that modern nomad trying to run a business from the road, this is what your day suddenly looks like with this tech. First off, unbroken 4K video streams without any lag, even if a giant storm cloud rolls in or a tree blocks your dish. Second, you have zero reliance on external cloud authentication. That onboard pfSense router acts as your own secure local gateway, handling all your VPNs and firewalls locally. That is absolutely crucial for protecting sensitive corporate data. Third, that direct-to-12V efficiency means you're preserving your vehicle's battery banks for your other off-grid needs. And for the really high-end deployments, there's an optional air-gapped Edge AI agent. It's a localized computing core that runs entirely offline, meaning your highly sensitive scheduling and operations never touch public cloud networks. There's a quote from the source material that really hits the nail on the head regarding why this level of engineering is just so necessary. It says, "When you are operating an off-grid operations base, a drop in connection is more than an inconvenience. It is a critical failure point." And it's so true. Whether you're an executive trying to close a multi-million-dollar deal, or maybe an industrial user flying heavy-lift drones beyond your line of sight, you simply cannot afford a 30-second software failover. Seconds of downtime literally mean mission failure. That's exactly the latency that Gen 5 technology was engineered to eliminate. Okay, let's bring it all together in our final segment, Section 4, WISP base versus LTE. How do you actually choose your Gen 5 gateway? Let's actually break down the hardware options here. The WISP-in-a-Box base, which comes in at $1,497, is basically your foundational entry-level tactical gateway. It gives you a modified cellular bonding bridge and that incredibly important onboard pfSense local gateway, but you do have to bring your own Starlink equipment and mount it using their provided hardware. On the flip side, stepping up to the WISP-in-a-Box LTE for $4,997 gets you a premium, fully turnkey dual WAN communications engine. They call it a combustion engine design. It integrates a high-performance LTE compressor and a Starlink radio transceiver right into one cohesive communications bus. No dangling modems, no cheap plastic cases. Everything is safely housed inside a custom 3D-printed, honeycomb-ventilated Nomad shell that's built for severe environmental stress. And that awesome sub-millisecond failover we talked about, it's entirely pre-configured right out of the box. Honestly, that pre-configuration is a massive benefit. When you grab the premium LTE version, all the scary networking complexity vanishes. These units are actually custom-tuned at the Articular's workshop for your specific mission profile before they ever even ship. So whether you're outfitting an agricultural robotics system, slapping a marine mast array on a boat in damp sea air, or decking out an extreme overland command station, the techs pre-tune all the routing configs, the vSIM profiles, and the security keys. It's completely optimized for your exact environment the second you plug it into your 12-volt system. So we've covered how Gen 5 connectivity is completely transforming that old, chaotic consumer patchwork into a truly unbreakable, enterprise-grade solid-state system. It gives remote executives total security and zero lag, running cleanly right off the vehicle's DC power. So I want to leave you with this thought to reflect on. If your connection is unbreakable anywhere on Earth, where will your corner office be tomorrow? Thank you so much for joining me for this explainer, and I really hope this inspired you to rethink the absolute boundaries of remote work and mobility. Catch you next time.